Hey, for the latest news, go to SCTE.org for standards, training, certification, events, even membership. Everything you need to know, SCTE.org.
DWDM tuning box offering, so the TN100 SBT. It's available on Apple and Android and Google Play. It's a free download. If you work for Comcast, congratulations, you get the support and service at the cost of the box. If you are a contractor, unfortunately, we have to sell you guys software licenses. But anyway, so purpose behind the tuning box. Let's see where I can start with this. So
Yeah, let's start that one over again.
Yeah.
And hopefully we can cut that part out.
Okay.
Because I don't necessarily want to differentiate whether the MSOs or operators or whatever, but just talk about the features of the tuning box. So effectively, you go to the Google Play Store or the App Store and you download the companion app to the tuning box, and that is assuming Bluetooth connectivity to the tuning box to be able to connect to and tune your optics to whatever channel you choose. That's pretty slick.
Yeah. We've really loved the Bluetooth feature. So historically, before this, the Bluetooth tuner, everything was a laptop connected tuner or device, and didn't provide for a whole lot of flexibility. Primarily if you're an operator and you're up in the bucket truck, like you could just take your phone out, take this tuning box out, and tune from the bucket truck. It additionally offers some other features in addition to tuning. There's some diagnostic features, which I don't know how much you want me to dive into that. Funny enough, that's actually something I'm going to be talking about next week when I'm down in Keystone working with a lot of your guys. So
so it is a lot of flexibility, right? Once you have the box, you can either USB connect it to a laptop for maybe inside plant applications to tune an SFP for the chassis and the head end versus being in the outside plant. You could connect to it with the smart device via Bluetooth to tune the SFP for the node. So very flexible, easy to use option there, either in a laptop based or through the Bluetooth free apps.
Yep.
So there's a commercial for the Precision Optical Tuners, the TN100 SBT Tuning Transformed SFP Tuner.
Yep. So one other thing I did want to mention with the tuner, you don't use a tuning box all the time with tunable transceivers. When it comes to the remote PHY devices, it sounds like you would use a tuner at all times. But for switches and routers, primarily in the head end, that have software built to support tuning, you would just tune through the CLI of the switch or router. But a lot of the old legacy equipment that was never written for it, you would use a external tuning box similar to the one we show here.
All right. Hey, do you have the slides on the PON and rural broadband applications? Did you want to cover that one?
I should. It's on the other file.
And there's another slide in. I'm wondering if it's this deck on transceiver specified operating optical characteristics that I think is pretty interesting. Might be 44. Maybe not.
You said 44.
Yeah.
Oh,
Actually, it looks like 42. Yeah,
there we
that
go.
one.
There we go. This one. Okay.
Yeah. So I think that's an interesting slide too that may help simplify a couple of different things, particularly around different wavelengths of light, all the way from, Y-ray and X-rays, all the way up to industrial beam and sort of everything in between, and where we exist on the visible light spectrum versus the wavelengths and the colors that we actually use to transmit data through, whether they be, CWDM or DWDM. I think that's kind of interesting to think about as a technician. When we think of light, we think of the light that we see most of the time, and that light has colors, and that's dependent on the wavelength. But when we start talking about light and optics, it's not that dissimilar, really. It's just very, very specific wavelengths and colors that we use to transmit data with.
Yeah. No. Absolutely hit the nail on the head. We can't see the light, but yeah. Actually, CWDM was notorious for this, where they actually used a color coding system on their optics, where if you got it from some sort of manufacturer, they might say, "Oh, a red bale implies it's a 1450. A green bale might imply that it's a 1510," and they were able to do that on CWDM because typically CWDM, I know it says 18 channels here. You're seeing typically maybe at most using 12, oftentimes just 8. So you could easily use a color coded system there to differentiate. You get to DWDM and that really doesn't matter anymore. You've got 48 possibilities. You're going to have 50 shades of gray on the bale. So manufacturers went away from the color coding scheme there. But yeah, you do have very specific operating, optical characteristics, like very specific ranges that are used. And honestly, you could probably do an entire afternoon lecture explaining why specific wavelengths are used. And a lot of it, at a high level, really just comes down to scientific research has shown that those are the wavelengths we need to use to maximize how far and we can shoot the signal and how we can maximize how much data is being used. Like you'll see, we don't use visible light wave or light wavelengths in fiber optic networking. And off the top, yeah.
And a lot of that has to do with the properties of glass that we're pushing the light through too, right?
Yeah.
Because there's certain wavelengths that just don't propagate as well through the fibers that we use. So therefore they're not as desirable from a quality or a data rate standpoint.
Yeah.
So you're right. That could be an entire different afternoon of discussion.
Yep.
But yeah, that one's helpful in just sort of differentiating between, CWDM, DWDM, where the visible light is on the spectrum array versus UV, X-ray, microwave, and other types of radiation. So, light really is radiation. It's just a very specific frequency or lambda of radiation, and some of which we can see and some of which we can't. But a lot of them are useful for different applications, and particularly, the one we're talking about today, which is, transmitting data over glass.
Yeah.
Okay. Let's talk about PON and rural broadband. I know that's a big topic of conversation for a lot of places, particularly as, America is really intent on building out a lot of the underserved areas in the country.